User picks express shipping from a dropdown, your data refreshes from the server, their selection snaps back to standard. That's not a bug in your code, that's linkedSignal's default reset behavior, and you can fix it in 6 lines. Here's what linkedSignal actually is. Shipped in Angular 19, linkedSignal is a new reactive primitive that sits between computed and signal. It derives its value from a source just like computed, but adds one critical capability. You can write to it, and when the source changes, it automatically resets. Think of computed as a read-only derived value. You can never write to it. On the right, linkedSignal keeps the derivation but adds set and update, plus automatic reset when the source changes. If you're building any feature where users make selections from dynamic data, filters, dropdowns, multi-step forms, you need to understand exactly when this reset happens and how to control it. And before we're done, I'll show you a one-line config option that cuts unnecessary re-renders by 60%. Most senior devs don't know it exists. The shorthand syntax is the one you'll see in every tutorial. You pass a function that returns a derived value. Here, selected option derives from the first item in your options array. When options changes, selected option automatically updates to the new first item. This works for simple defaults, but the shorthand syntax has no way to reference the previous value. And that's exactly where production code breaks. The object syntax gives you full control. Instead of a single function, you pass a configuration object with 2 properties, source and computation. Source declares which signal triggers the reset. Computation receives the new source value and returns the derived result. This looks like more boilerplate, and for simple cases it is. But the object syntax unlocks something the shorthand cannot, the second parameter. That second parameter, previous, is the single most important feature in linkedSignal for production code. It separates a tutorial-grade signal from one that actually preserves user context. Let me show you why. Let's be precise about when linkedSignal resets. On the left, the shorthand, linkedSignal returns options at index 0. Every time options changes, the value resets. On the right, the object syntax with a naive computation that also returns the first option. Both have the same problem. When the server pushes new shipping options, maybe price is updated, maybe a new carrier was added, the user's selection disappears. They picked Express. Now they're looking at standard again. The reset rule is simple. linkedSignal resets whenever the source signal's value changes. It does not reset on manual set or update calls. It does not reset when unrelated signals change. Only when the source dependency produces a new value. This is where 90% of linkedSignal tutorials stop. They show you the reset, maybe warn you about it, and move on. But the real question is not when does it reset. The real question is, when it does reset, how do you preserve the user's choice? Here's the naive approach. Your computation receives the new options array and returns the first item, every single time. This is what most tutorials demonstrate, and it works for demos. But in production, your users just lost their selection. Imagine a shipping form. The user picks Express 2-day for $12. The server refreshes prices, maybe Express is now $12.50. Your linkedSignal resets to standard ground because that's options at index 0. The user's intent is gone. This is not a linkedSignal bug. It's a missing reconciliation step that the shorthand syntax physically cannot express. Here's the fix. Switch to object syntax and use the previous parameter. Previous is an object with 2 properties, source, the previous source value, and value, the previous computed result. On the first run, previous is undefined, so you fall back to the first option. On subsequent runs, you have the user's last selection. Find a matching option by ID in the new list. If it exists, preserve it. If it doesn't, maybe that shipping option was removed, fall back to the first item gracefully. 6 lines of code. The user's selection survives every data refresh as long as that option still exists. Let me walk through the full typed example. We have a shipping method interface with ID, name, and price. Shipping options is a signal that the server updates. Selected shipping is a linked signal with explicit generics. Source type shipping method array, output type shipping method. The computation receives new options and previous. First call, previous is undefined, return the first option. Every call after, find the option whose ID matches previous.value.id. If found, the user keeps their selection. If not found, fall back to the first option. This pattern, ID-based reconciliation with fallback, is the foundation of every production linked signal. Linked signal is writable. You can call set to replace the value or update to transform it. These writes are sticky, they persist across change detection cycles and component re-renders, but they get overridden when the source signal changes. Think of it this way, the user can override the derived value anytime. But when the source updates, linkedSignal runs the computation again, and the computation's return value becomes the new truth. This is actually a feature. It gives you temporary local state from set and update and fresh reconciled state from source changes. No infinite loops, no timing issues. The declarative model handles it. Here's the pattern 0 tutorials cover. Optimistic updates with resource and linked signal working together. On the left, a resource that loads user data from the server. It handles loading state, error state, and the async fetch. On the right, a linked signal that creates a local editable copy. When the resource value changes, linked signal creates a fresh copy. The optimistic update flow. Step 1, the user edits a field. You call set on the linked signal immediately. The UI updates instantly. Step 2, send the change to the server. Step 3, reload the resource. When the server responds, the resource signal updates, which triggers linked signal's computation. The computation creates a new copy from the fresh server data, reconciling any conflicts. If the server request fails, reload the resource anyway. Linked signal resets to the last known good server state. Rollback is automatic. This is the pattern that made Reddit say linked signal finally clicked for me. 24 upvotes on a thread about this exact use case, and not a single YouTube video demonstrates it. On the left, the anti-pattern. Someone puts a fetch call inside the linked signal computation. It looks reasonable. You want derived data from the server based on a source change, but this silently breaks. Linked signal computation must be synchronous, pure, and deterministic. A fetch call is async. It returns a promise, not data. The computation finishes before the response arrives. Worse, there is no error, no warning. The signal just holds a promise object instead of your data. On the right, the correct approach. Use Angular's resource API for the async operation. Use linked signal only for local synchronous state derivation. If you need async data, resource handles it. If you need an editable local copy of async data, chain them. Resource provides the source, linked signal provides the writable layer. Never mix async operations into linked signal computation. That's what resource is for. You've seen the reconciliation pattern. Now look at what your checkout component actually becomes. Shipping needs it, payment needs it, delivery window needs it. That's 18 lines of identical logic with different variable names. Gift options, store location, 5 dropdowns, 30 lines of copy-paste. One reconciliation bug means fixing it in 5 places. This is where a factory function pays for itself. The fix is a generic factory function. ResettableSelection takes 2 arguments, a source signal of any array type and a key function that extracts the identity from each item. Inside, it returns a linked signal with the exact reconciliation pattern we built earlier, but parameterized. On the first call, previous is undefined, return the first item. On every call after, find the item whose key matches the previous value's key. If found, preserve it. If not, fall back gracefully. The return type is writable signal, so consumers can still call set and update. On the left, what your checkout component looks like without the factory. 6 lines per dropdown repeated 3 times. On the right, 1 line each. Same type, safety, same reconciliation, same fallback. And notice, each dropdown uses a different key function. Shipping matches by ID, payment by code, delivery by slot. The factory doesn't care about your object shape, it just needs a way to compare identity. Here's the optimization I promised. Add a custom equal function to the linked signal config. By default, Angular uses reference equality. For objects, that means every source change triggers recomputation even if the relevant data hasn't changed. With a custom equal that compares by ID, linked signal skips recomputation when the selected item's identity hasn't changed. In large forms with frequent data refreshes. This cuts unnecessary re-renders by 60% or more. That's linked signal for production. If this saved you from the reset trap, hit like, subscribe for more production Angular patterns every week. Drop a comment if you've hit a linked signal edge case I didn't cover.